Every type of meteorite. Space is complicated. We make it simple. Every meteorite that has ever landed on Earth is a piece of somewhere else delivered for free with no spacecraft required. Some are leftover building material from the earliest days of the solar system, untouched for over 4.5 billion years. Some are literal pieces of Mars and the moon, blasted off their homeworld by an ancient impact and sent drifting until they happen to intersect Earth's orbit. Every category on this list is a real confirmed type of space rock that has actually been found, cataloged, and studied, sitting in a museum or a laboratory somewhere on Earth right now. We're going in order from the most common to the rarest, most exotic type. Then we'll sort them a second way by how old each one actually is, because on this list, ancient and recently formed can differ by billions of years. Stony meteorites, chondrites. We begin with the most common type of meteorite found on Earth by an overwhelming margin, and also, in a specific way, the most scientifically valuable. Chondrites are stony meteorites that have never been melted or significantly altered since the solar system's earliest formation, meaning they're essentially unprocessed leftover building material from the original disk of dust and gas that the sun and every planet eventually condensed out of. Here's the fact that should genuinely bother you, because chondrites have remained geologically unchanged for over 4.5 billion years. They represent the closest thing scientists have to a physical sample of the raw ingredients the entire solar system was originally built from. Older than any rock ever found on Earth's own constantly recycled, tectonically active surface, and in some cases containing tiny mineral grains that predate the sun itself, formed inside a completely different, older star that exploded before our own solar system ever began to form. Here's the part that lingers. Certain rare chondrites, called carbonaceous chondrites, contain amino acids and other organic compounds, meaning some of the basic chemical building blocks associated with life have been directly confirmed inside rocks that fell to Earth from space. A genuinely serious data point in the broader debate over whether life's raw ingredients might be common throughout the universe rather than a one time Earth specific accident. Stony meteorites, achondrites. Here's the twist. Unlike chondrites, which have never been melted, achondrites are stony meteorites that clearly have been, evidence that they broke off from a larger parent body large enough to have differentiated internally, separating into distinct layers the same way Earth itself has a distinct crust, mantle, and core. Here's the fact that should genuinely bother you. This means every achondrite meteorite is a fragment of a failed or destroyed protoplanet, a body that was large enough and hot enough early in its history to begin the same layering process that formed Earth before something, usually a violent ancient collision, shattered it apart long before it ever finished becoming a full planet. Here's the part that lingers. The asteroid Vesta, one of the largest objects in the asteroid belt, is believed to be the confirmed parent body for an entire specific family of achondrite meteorites, meaning scientists were able to directly match rocks sitting in laboratories on Earth to one specific still existing object in the asteroid belt. Based purely on matching chemical signatures, a rare case of tracing a meteorite not just to a general category, but to one specific individually identified source object, still visible through a telescope today. Iron meteorites. Here's the reframe. This category isn't stone at all, but solid metal, and it represents something genuinely unique, a direct physical sample of a planetary core, delivered to Earth's surface without ever needing to drill through an entire planet to get one. Iron meteorites are composed almost entirely of iron and nickel, believed to be fragments of the metallic cores of ancient, differentiated protoplanets, exposed only after violent collisions stripped away the rocky mantle and crust that would have otherwise permanently buried that metallic material deep inside. Here's the fact that should genuinely bother you. Earth's own core, similarly composed of iron and nickel, discussed elsewhere on this channel in the context of the planet's magnetic field, is completely inaccessible to direct study, buried under thousands of kilometers of rock, meaning iron meteorites are, right now, the only physical samples of this exact type of material humanity has ever been able to directly hold, chemically analyze, and study in a laboratory a genuine substitute for a planetary core sample that no drilling technology on Earth could ever actually retrieve. Here's the part that lingers. Some iron meteorites display a distinctive crystalline banding pattern called a Widmanstetten pattern, visible only after the metal is cut and etched. That forms exclusively when molten metal cools at an extraordinarily slow rate over millions of years, meaning the pattern itself is direct physical proof of just how long these fragments sat, cooling inside their parent body before that body was ever destroyed. Stony iron meteorites, Pallasites. Here's the fact that closes the gap between the two previous categories with what many meteorite collectors and scientists consider the single most visually striking type on this entire list. Pallasites are a rare stony iron meteorite type containing a metallic iron nickel matrix embedded with large, often translucent olive green crystals of a mineral called olivine, believed to have formed at the exact boundary layer between a differentiated protoplanet's metallic core and its rocky mantle. Here's the fact that should genuinely bother you about how specific this formation is. This exact boundary zone represents an extraordinarily narrow, precise physical location within a planetary body, meaning Pallasites offer scientists a uniquely detailed window into exactly what that specific transitional layer between a core and a mantle actually looks like. A boundary that exists somewhere inside every differentiated planet, including Earth, but remains completely inaccessible to direct study anywhere else. Here's the part that lingers. When cut into thin slices and lit from behind, the embedded olivine crystals in a pallashite glow with a striking glass-like translucency, meaning some of the most scientifically informative meteorites ever found are also, by pure coincidence, considered genuinely, strikingly beautiful objects in their own right. Lunar meteorites. Here's the fact that pushes this category from somewhere in the asteroid belt to a source everyone can actually picture directly. Lunar meteorites are confirmed fragments of the moon's own surface, blasted free by ancient impact events, energetic enough to throw debris entirely clear of the moon's comparatively weak gravity, material that then drifted through space for an unknown period before eventually intersecting Earth's own orbit and falling to the surface. Here's the fact that should genuinely bother you. These meteorites are confirmed as genuinely lunar in origin by directly comparing their chemical and isotopic signatures against the confirmed lunar samples physically returned by the Apollo missions, meaning humanity's own crude moon landings inadvertently created the exact reference library needed to later identify these free, naturally delivered lunar samples turning up in random locations on Earth's surface. Here's the part that lingers. Lunar meteorites represent locations on the moon's surface that no crewed or robotic sample return mission has ever actually visited, meaning some of them may be providing scientists with geological information about regions of the moon that remain to this day completely unexplored by any spacecraft at all. Martian meteorites. Here's the fact that closes the gap on the farthest confirmed natural delivery on this entire list. Martian meteorites are confirmed fragments of the surface of Mars, ejected by ancient impacts powerful enough to overcome Mars's own gravity, a significantly greater escape challenge than the moon's given Mars's larger mass, meaning any impact capable of producing a Martian meteorite had to be genuinely catastrophic. Here's the fact that should genuinely bother you. These meteorites were confirmed as Martian in origin specifically by comparing tiny pockets of trapped atmospheric gas found sealed inside them against the atmospheric composition measured directly by NASA's Viking landers on the Martian surface in the 1970s, an exact chemical match that left essentially no reasonable doubt about their true origin. Here's the part that lingers. One particular Martian meteorite, discovered in Antarctica and designated AL-Heidi 4001, generated genuine, serious scientific controversy in the 1990s when researchers identified microscopic structures inside it that some interpreted as possible evidence of ancient microbial life, a claim that remains disputed and largely unconfirmed today, but that briefly made a rock that fell from the sky into one of the most consequential, most publicly debated objects in the entire history of the search for life beyond Earth. Tektites, glass formed by impact rather than delivered from space. Here's the fact that closes this list on a genuine, deliberate exception: an object that isn't actually a meteorite at all, despite being closely related to the same violent process and commonly confused with one. Tektites are small, glassy objects formed when a large asteroid or comet impact on Earth's own surface melts and violently ejects terrestrial rock, which then cools and solidifies into glass while still airborne before falling back to the ground, sometimes at a location thousands of kilometers from the original impact crater. Here's the fact that should genuinely bother you. Because tektites are made from Earth's own native rock, melted and reshaped by an impact rather than being extraterrestrial material itself, they technically don't qualify as true meteorites at all, despite being found scattered across the ground in the exact same way meteorites are, and despite owing their entire existence directly to an object that did come from space. Here's the part that lingers: large fields of tektites, scattered across huge geographic areas, are sometimes the best surviving physical evidence connecting to an ancient impact crater that has otherwise been completely erased by weathering and geological time, meaning these technically not meteorites can end up being the last remaining physical clue that a genuine meteorite impact ever happened at that location at all. Micrometeorites, the meteorites falling on you constantly. Here's the fact that closes out the categories with the smallest, most overlooked entry on this entire list, and also the most common by an overwhelming margin. Micrometeorites are tiny fragments of space debris, typically smaller than a grain of sand, that survive atmospheric entry intact and settle gently onto Earth's surface constantly, all over the planet, rather than arriving as a single dramatic streak of light. Here's the fact that should genuinely bother you. Earth accumulates an estimated several thousand tons of this material every single year, meaning micrometeorites represent, by sheer total mass delivered annually, the single largest category of extraterrestrial material actually reaching Earth's surface, dwarfing every dramatic, museum worthy meteorite on this list combined. Here's the part that lingers. Because they're so small and so easily mistaken for ordinary terrestrial dust, scientists specifically collect them from locations kept unusually clean of Earth's own contaminating debris, including Antarctic ice cores and the sediment layers of deep ocean floors, meaning some of the most abundant space material on the planet is also, ironically, some of the hardest to actually notice without deliberately searching for it in exactly the right place. Let's sort these eight again a different way, not by rarity, but by how old each one actually is. On the oldest end, chondrites, essentially unaltered since the literal beginning of the solar system, over 4.5 billion years old and never significantly changed since. On the ancient but processed end, achondrites, iron meteorites, and pallasites, all formed slightly later than chondrites, once a large enough parent body had time to melt and differentiate internally before being shattered apart. On the comparatively recent end, lunar and Martian meteorites, ejected from their homeworlds far more recently in geological terms, sometimes within just the last few million years, a tiny fraction of the age of the solar system itself. And on the genuinely modern end, tektites, which can be created anytime a sufficiently large impact happens to strike Earth's own surface, meaning new ones are, in principle, still being actively created today, right now, somewhere on the planet, whenever the right kind of impact occurs. It's worth being clear before we close about exactly how meteorites get their scientific names in the first place, since it directly shapes how this entire catalog is organized. Every confirmed meteorite is officially named after the specific geographic location where it was found or observed to fall, regardless of what world it actually originated from. Meaning, names like Allende, Murchison, or Chelyabinsk describe an arrival point on Earth rather than anything about the object's true origin at all. Here's the fact that should genuinely bother you. This naming convention means two meteorites that landed on opposite sides of the planet decades apart could be nearly chemically identical fragments of the exact same parent body, or even the exact same original impact event. And their official names would give absolutely no hint of that shared origin at all. The true relationships between meteorites in the same category only get uncovered later through careful laboratory chemistry, entirely separate from whatever a rock happened to be named after the field or town it was found in. Here's the last thing worth sitting with. Every meteorite ever found on Earth's surface is a message delivered without being sent. No spacecraft, no mission planning, no controlled trajectory, just billions of years of random orbital mechanics eventually placing a piece of another world directly in Earth's path. Somewhere on this planet right now, sitting in a field, a desert, or a museum display case, is a piece of the moon, a piece of Mars, or a piece of a planet that no longer exists at all, and it got here entirely for free. Not bad for stick figures on a rock.